My name is Banani. I work as a senior manager of AI ML product data science at Walmart. I'm excited to be here today to talk about how we can accelerate insight generation using generative AI through our multi phase architecture for scalable metric summarizations. Cool. So, in large organizations, business leaders and teams depend heavily on metrics, whether it's member churn, active users, sales trends, or experiment results. These metrics guide crucial decisions. Yet, the process of turning raw data into trusted, actionable narratives is slow. It's often inconsistent and very hard to trust. So, this creates bottlenecks and misalignment. So, today I'll walk you through the problem we faced, the system we designed, and the outcomes we are achieving. By the end, you will see how a structured, phased approach can scale metric insights while maintaining accuracy, governance, and trust. Moving on. So, the problem we set out to solve is that weekly KPI narratives were slow to publish, inconsistent across teams, and sometimes not reliable. Analysts spend countless hours pulling data, reconciling definitions, and manually writing summaries. Meanwhile, executives lacked a single trusted source of truth. So, let's make this more concrete with an e commerce example. Imagine you're tracking weekly sales uplift after a holiday campaign. Marketing reports a 5% increase, while finance claims it as 3%, and operations sees inventory shortfalls but can't connect them to sales lift. So everyone is working from different spreadsheets, timelines, and assumption. And what the result is? Confusion, right? We have wasted time, we have delayed action, and this is exactly the pain point that we're trying to solve here. And our target outcomes are very clear. We want to reduce the time to publish, we want to improve the numeric accuracy of the data. We want to ensure the citations and the ground claims to be clear and deliver narratives in a style that is tailored to different audiences. It could be executives, product managers, or operation teams. Now, to make it even more clear, this slide illustrates the before and the after experience for the analysts and the decision makers. As mentioned earlier, too, the process is highly manual. Analysts pull 50 to 100 KPIs from multiple dashboards and export them to spreadsheets. To understand context, they chase across systems like where are the A/B test registries, are there any incident Jira tickets, are there promotion calendars and Slack threads. So then they manually write executive or PM notes, editing wording to fit the in house style. Now, this entire process takes nearly 6 to 8 hours and sometimes produces inconsistent phrasing and often leaves causes which are uncited. But with this, our three-phase pipeline that we will be discussing in the subsequent slides, the workflow is entirely transformed. The system flags significant changes, builds the payload, and assembles a context pack. The model produces schema log drafts with citations tailored for executives and analysts. We also, there could be a human reviewer that just checks the confidence levels and makes one to small edits and send it to the required audience, right? So this helps in reducing the time to 1 to 2 hours. It makes the voice very consistent. The themes are more reliable. Explanation are there for the different anomalies. And this change is just not just about efficiency, it's about building a system that helps us understand the trust and scalability. And leaders can also act very fast with reliable narratives that is grounded in data and evidence. Cool. Moving on. So this let's move to a solution that is grounded in what we call as data contracts, right? So it had this architecture has three layers. First is the data layer, second is the intelligence layer, and the third is a delivery layer. What we have in data layer is often we have hive tables, we have the registries, experimentation, event calendars, and ownership tags. Think of it as a system of record, right? For example, let's say we want to understand the weekly active members and the sales by region or the churn rates. All of these individual data points generate in this layer. The moving on to the intelligence layer. So this is where the contracts, retrieval, and AI models operate. So this layer applies anomaly detection, assemble our context packs, enforces the glossary rules, and prompts the LLMs to generate schema locked summaries. So, because that's our true outcome. And it helps to transform data into insight while embedding guardrails like numeric locking and citation requirements, which will we expand in the subsequent slides. And the third layer is a delivery layer. Finally, the insights that are transformed from the intelligence layer, here they are distributed to audiences in tailored formats, right? We want to create more executive dashboards. We want to give briefs to our product managers, or we want to generate operational reports, right? For example, in retail, an exec might just want to know a very basic, give me the weekly active members, which grew by 3.2%, and the so and so was driven by this new product launch or other factors, while ops team needs a very deeper breakdown by, let's say, segment, drivers, etc., right? So by layering in data, intelligence, and delivery, and anchoring all in a sort of a contract format, we are ensuring that the AI produces consistent, accurate, and audience appropriate insights. Moving on. So, in phase one, we discussed about building a pipeline, right? So, the first comes the phase one. So, here we begin with retrieval. The metrics and segments are pulled from the high tables using SQL and PySpark queries. We run anomaly detection scripts in Python to flag significant changes and then structure the outputs into JSON payloads. Each payload includes the metric, time window, detected change, and top segments. After that, we prompt a LLM or a large language model to generate a schema-locked summaries, strictly adhering to numbers and format. The guardrails like no causal claims without validated drivers. This definitely helps us enforce a discipline and prevents any kind of speculation that kind might be embedded in the data. For example, to make it more clear, in retail, we might this per phase one might produce a weekly active members grew by 3% week on week, and then to 1.2 million, quantifying the increase. It could also give you further deeper cut on the new members who have joined our program in last 30 days rose to 8%. That is driving 30% of our share, right? So we can clearly see from the messaging or the outcome of this phase one, it's consistent, and it also, but it's the point is it still doesn't explain why the growth happened, right? And this benefit of speed and consistency, but the context that is missing will help us and leads us to the phase two. Now, moving on to understand phase one a little bit more better, this slide shows how phase one actually works step by step. So, we start with the matrix dictionary and glossary. These keep everyone speaking the same language. For example, always saying member churn instead of using different terms for that. Next, the metric store tables highlighted here provide the raw numbers like weekly active members, segment breakdowns, etc. A simple Python based anomaly detector then helps us highlight the important changes. For example, the deviation in positive or negative direction. The example that we just walked over, like the 3% week on week change or the 8% growth in the new members, all of these are stored in this table. Then this information is bundled into a payload snippet, which is basically a structured JSON file with the facts, segments, and any validated drivers. And that JSON becomes the input for the LLM. And behind the scene, the process runs through familiar tools. We have Airflow to orchestrate, we have Docker to package, and we also have APIs to deliver our results. Now, the key highlight here is the leaders don't see any of this complexity, right? What they actually require or is given is basically the exec render, which is the final part. A short, clear story like this way, this is the fluctuation in the metrics, and this is driven by so and so factors, and who is owning up the next steps, right? Here, as we mentioned, growth analytics to monitor cohort quality. PM has to launch to finalize the rollout playbook. So all of these in the phase one, whatever we implemented, is put in this format. Cool. Hopefully the phase one is clear. And now let's go to the phase two, right? This is where the things get more interesting. So instead of just pulling raw numbers, we also want to bring the surrounding context, right? We haven't still now understood why all of these metrics change as is, right? So for that, we need to understand the recent experiments. We need to get the understanding of incidents, the notes, and the event logs if possible. So all of this information, what I mentioned, is pulled together into a context pack. Think of it as a fact bundle, right? It has metric values, the segments, and a list of possible drivers. The model then uses this pack to generate summaries that are not only accurate but also grounded in real evidence. So every causal claim must point back to a source. And we also get a confidence bar in this very particular phase, like how from 0 to 100, how confident we are in the outcome of this phase 2. And if the confidence is low, then the system simply falls back to a safe, descriptive version and flags it for the review. And importantly, this phase builds directly on what we had in phase 1. On top of the contract first metrics and anomaly detection, we add here this orange bars, the retrieval, ranking, and citation checks. And in other words, phase 1 gave us consistency, but phase 2 adds an explainability and the traceability aspect. So, from a technical standpoint, what it means is retrieval is typically handled with vector databases, like most commonly uses FIS or Pinecone, where documents are embedded and fetched using a semantic similarity. On top of that, the ranking layer, which is usually hybrid scoring or BM25 mechanism, that helps us prioritize the documents which are most relevant to the metric and the time window for our analysis. So, and finally, the citation checks we mentioned here ensure that any causal statement that we mentioned is tied back to a specific document ID to add that level of trustworthiness. So, going back to the retail example that we have been building so far, instead of just saying from the phase 1, like, active members grew, the RAG can add additional context, like driven by the new product launch, which has been ramped to 100%, and so on. So, from this time. And this ensures that the story now has both the number and the explanation with the receipts or evidence included. So moving on, like someone needs to ask, like, why do we need two different phases? And this slide highlights the differences between both. In phase 1, the inputs were very limited to metrics only. Explanations were descriptive and there were no citations. In phase 2, we added the RAG or a retrieve context that helps us with causal claims and required more citations to add evidence. Now, confidence is being smarter if the model isn't sure, right? So it falls back to safety outputs. Now in phase 2 also, the security is tighter too, so with the role scope retrieval and the PII filters that we leveraged, the output now includes both the drivers and the citations, making it much easier to trace back it to the source. So of course one can argue that it requires more infrastructure, more planning, more larger time. But then the gain that we get from this phase 2, which is a trust and explainability, is really emphasizing why we need both the phases in sequence. Cool. Moving on. So the phase 2, which is this slide shows how the RAG pipeline actually works. So on the left, you see the retrieval hint payload. This is what the system uses to go fetch the right context. And it specifies the metric, time window, segments, and what kind of documents we need, such as the experiment or incidents. In the middle is the context pack. So this is the retrieved output, combining the facts with candidate drivers. For example, it might list both a product launch or a latency incident as possible explanations. So each with its own individual confidence scores. On the right hand side is the output of your phase 2, which is LLM input. Here we merge the facts with highest confidence drivers, run them through the schema and guardrails as before. And the result is a summary that explains changes along with citations and the rules. So, together, these steps show how phase 2 moves beyond plain reporting into more explainable, evidence backed insights. Cool. Moving on, phase 3 is where we close the loop. Phase 1 gives us consistency, phase 2 gives us explainability and citations, and now phase 3 makes the system sounds more like our organizations or like us, on brand, clear, and actionable. And this phase has two parts: online runtime, which is phase 3A, and offline training loop, which is phase 3B. So why it's needed is, even with why we need the phase 3, right? Even with phase 2, the summaries can feel more generic or templated. Analysts have to spend time rewarding for tone, emphasis, and clarity. And phase 3 reduces that overhead by teaching the system our editorial side and the decision priorities. So in the online 3A, as shown in the slide, now the pipeline stays mostly the same throughout the steps 1 to 6 as we had before. The big additions are the step 7 and 8, the fine-tuned summarizer, which is typically built on top of an instruction tuned LLM, such as Llama or GPT style open models, or flat variants also you can use. and this helps us generate the 2 to 5 schema locked candidates. Fine tuning is usually done with lightweight adapters like LoRa to teach the model our domain vocabulary and how style without retraining from scratch. Each candidate is slightly different in phrasing, tone, and emphasis. For example, one may focus on customer impact and the other may focus on revenue impact. So the preference re-ranker, which you see here, then evaluates these candidates against the editorial rubric of our organization. Algorithms commonly used here as pairwise ranking models. We can use direct preference optimization, which is called DPO, and this helps us learn the feedback which style resonates faster. And the re-ranker selects the highest scoring candidate as the final summary, and is it's not correct but also very crisp and useful. So going back to the example, right, how do we make it work? So in e-commerce, a phase 2 output might say sales rose 4% week on week driven by promotion campaign. An editor might rewrite it into sales rose 4% week on week driven by promotion campaign, improving conversion for new customers. So what it says is phase 3 now observes that preference or the emphasizing on the customer experience. So next time the AI produces the improved version, which is like out of the box. So what it helps in result is fewer manual edits. It helps us faster publishing and summarizes summaries that are not just accurate and explainable, but also exactly sound like an organization or what the executive leadership want. Cool. Moving on to the offline phase, this is important. It's important to know that the online pipeline, which is the previous slide, directly depends on this offline training. So the fine-tuned summarizer, preference re-ranker, use that runtime are the models that are produced and validated in this offline loop and then deployed to production. So without this offline cycle, the online step would not continuously improve and would not stay aligned to our standards. So we collect gold summaries and editor listings here. We build data sets, preference pairs, then we fine tune the summarizer with LoRa, and then we create a JSON schema out of it. So next, we train the preference model also with a pairwise ranking, what we discussed before. Evaluation covers numeric accuracy, citations, rubric checks, etc. And we also add a safety and a governance layer to it, so that on a feedback layer, so that we can continuously leverage the retraining method. So, uh, moving on. Now, this is the comparison slide to showcase why phase 3 matters. It has been consolidated into a table. This definitely helps us process all the factual accuracy and auditability of phases 1 and 2. But on top of it, adds a sort of a style, prioritization, and a continuous learning loop. So the outcome becomes, and the summary becomes completely on brand. We have action oriented summaries, and this definitely reduces the effort and increases our leadership trust. Moving on quickly to the evaluation, governance, and cost, right? This is a very critical slide. So now we have built a pipeline that is explainable and consistent. So the last piece is to make sure it actually runs safely and reliably once it's live, right? So that's where this controls come in. Now, evaluation happens in two ways. We have offline evaluation, online evaluation. Now, offline, before anything goes out, we check that the numbers match 99% or better with every causal claim, at least from two sources. And the summaries are well documented, they are more clarity, concise, and very actionable. So we also run regression tests to make sure no unsupported claims slip through. Now, on the online evaluation part, once we're running, we watch live metrics, and these could be edit rate, time to publish, decision latency. And here the aim is to keep the needs review below 5%. So most outputs are used right away, while also making sure satisfaction stays high. And in short, we are checking that the system isn't just accurate, but genuinely helpful to our consumers, right? In governance, the access is very role based. We have PIA filters, we have guardrail lock numbers. Every run is completely logged, starting from prompt, context, sources, and outputs. On top of that, we have red team reviews, which helps us understand the rollback plans, create clear data retention policy, and we also have checklists that are constantly maintained to factor in the governance part. Now, cost is also an important pillar, right? We have certain targets to meet. We should have 6 seconds latency, for example. We need to be available for 99% of the time. We have a strict cost for 100 summaries. So these controls help us understand to use small models for structure, larger ones for narrative, what should be the cache component, what should be the retrieval documents, it should be 3, 5, whatever that is, right? And then the ops. ops parameters like it should be a batch run or a real time data run, and what should be the template for rag and stuff. So these are all the factors that goes into deciding what cost it should be, right? And in a retail context, leaders can trust that weekly AI generate summaries. They rely on the campaign planning. How are they consuming it, right? Supply chain adjustments or churn monitoring to get more accurate and cost efficient responses or summaries. Now, let's bring all of it together, right? We have had discussion, so much discussion in different phases. So now we started with understanding the phase one, which is a prompt engineering. So here we start with contract first, schema locked summaries. Then we move to phase two, that's a RAG based, which adds context, citations, and explanations backed by real evidence. Then we move to phase three, which is fine tuning and alignment. Here we teach the model our voices and priorities with continuous learning that is built in. So the outcome overall is a big shift. What used to be very slow, manual KPI reporting is now very fast, reliable, and tailored for different audiences. And leaders get trusted insights quickly with a clear drivers and consistent style. So, if there is one key takeaway I want you to take from this presentation is contracts, not vibes, right? By grounding AI in rules, retrieval, and fine tuning, we make it practical, safe, and scalable for at an enterprise level. So, thank you, everyone, and I'm happy to take any questions after this.